Hey guys, we're going to talk about how to find the discriminant in quadratic equations. So we're going to look at a kind of a case-by-case basis, and the parts we're going to focus on are what number the discriminant is, and we're also going to focus on the number and nature. So we're going to work on these two parts. And the roots themselves you can find by using the quadratic formula, but we already talked about that in the last couple lessons, so we're not going to really focus on that. So the first one, the discriminant is a perfect square. So what that means is that the discriminant is under the square root, and if you have a perfect square under that square root, then the answer you're going to get out is going to be a whole number. So what you want to do is write down what the numbers represent. So A is 1, B is 3, and C is negative 10. And then you want to plug it into that part of the quadratic formula. So you have 3 squared minus 4 times 1 times negative 10. And then you can take the calculator and put that in the calculator. And then you got parentheses 3 squared minus 4 parentheses 1 and the negative 10. So you end up getting 49. So 49 is the discriminant, and that's a perfect square. It's the perfect square of the number 7. Now what that's going to tell us about the number of roots and the nature of the roots. Well, first off, we're going to have 2 roots. We know there are 2 roots, and you could check this with the calculator. And the nature of those roots. The roots are going to be rational numbers. They'll be real numbers, but they'll also be rational numbers. And the roots themselves are going to be unequal. So the numbers that we get for those are going to be different. Now, going on to the second case, well, what if we get one that's not a perfect square? So, same thing here. A is 1, B is negative 6, C is 7. Now I'm going to plug in my negative 6 in parentheses for B, and I'll plug in the 1 for A and the 7 for C. I'm going to go ahead and type that in. So we got negative 6 squared minus 4 parentheses 1 parentheses 7. We end up with the number 8. Now 8 is not a perfect square because 4 is the square of 2 and 9 is the square of 3. So what that changes for our roots, well, the roots are still real numbers. They're still real numbers. However, in this case, they're irrational numbers because the square root is going to be a decimal. It doesn't end. And the roots themselves, there's going to be 2 of them, and they're not going to be equal roots. Now, going on to C and D, you'll kind of see the same thing happen. This one says this one's going to be equal to 0. Well, I'm going to plug it in. It's going to be negative 10 squared minus 4 times 1 times 25. So I'm just going to speed it up a little bit. Again, you can write out what A, B, and C are. A is 1, B is negative 10, and C is 25. Now in this case, if the discriminant is equal to 0, well, we're going to have one answer. So we're going to have the roots, but the roots in this case are going to be equal roots because they're going to only touch at one point. The numbers will be real, and in this case they will also be rational because there's going to be no, in this case, no way we can't write a fraction with that. And in the case of a number less than 0, well, that would give us some square root that's a negative value. So the only values we would have for this are going to be imaginary. So if you do get a discriminant, let's say it was negative 4, that means your roots are going to be imaginary, and there actually are no real number answers. And how that would look on a graph if I was to sketch a graph of this, what you're going to see is the graph that would basically never touch the x-axis. So those roots come at 0, and they hit the x-axis. In this case, whatever side the graph is on, it's going to stay on that side. So as you look at each case, check back your notes to see the type of roots and how many there are for the cases of each of these. And if they do ask for what the roots are specifically, just remember to use your quadratic formula.